Hey everyone. So one of the things I talked about back in my Reimu project overview video was these randomized spell cards. Each card has 3 symbols out of 9 and 1 border out of 6. Every time I duplicate and make a new card, whether it's a Shift D or an Alt D, the new card has random symbols and random colors. I got a lot of questions about how this was done, and now I've gone and taken some time to revisit the node setup, clean it up, and this will be a video explaining how to make something like this yourself. I originally put this new setup together for my patrons, and I'd like to thank them all for their continued support. If you want to help me put out more content like this, please support me on Patreon, or you can pick up the file on Gumroad for a few dollars. I will be explaining how to make the whole setup from nothing, so you can also just follow along and build it for yourself. Let's take a look at exactly what we'll be making. First, I have 2 image textures that I hastily scrawled in Krita some time ago. There's 6 different borders, and there's 9 different symbols. We'll be learning how to build this node setup that randomizes them on the card, randomizes the colors, and also makes sure that different cards have different sets of each. The core of the node group is here. It's a group that lets us control which of the 9 symbols we have picked. We can control with different columns and rows, scale, rotate, whatever we need. Next is the larger group this is inside. This group lets us define a border on our UV vector so that our symbols don't get overlapped by the border texture. It also has the setup to split the card into 3 areas so that they can each get their own symbol. Then we have a group that provides us with random numbers, with some ability to control the range, and if they're random per object or even per mesh island. Although I'll note that the random per mesh island only works in cycles at the moment, but I think it's being added to Eevee very soon, so I decided to include it in the group. These core groups are then reused to build the rest of the node setup, including another similar group to randomize the borders, and using random numbers on our colors. We'll start off with a fresh file. I have my 2 textures, and I have a plane and my card. Both of the objects have completely basic UV maps. The plane does have some subdivisions just so that we can turn on mesh and clearly see where the symbols fall. But the UV map is just one unwrap that's been subdivided, and in the case of the card, even though it is a squished plane, its UV map is stretched to cover the entire UV space. Note that the node setup we're going to be using does work off the assumption that your UVs are scaled to cover the entire area. If you have some differently shaped UV map, if this was scaled to just cover one column of the textures and match the aspect ratio of the object, then you would need to do things a little bit differently. It doesn't change any major things, all the concepts apply, but you might need to do some remapping or skip some changes we make in the nodes because they're already in the base UV. But by the time we're done with this, you should understand what we're doing clearly enough that you can adapt it to your own UV map. And if you still have trouble, then of course, leave a comment or send me a message. Let's start with some basic theory. We need to know how we get just one of these symbols at a time. Basically, we need to do the equivalent of taking our UVs and scaling them down to just one corner, and then be able to move that around on our grid and select just one of these symbols at a time. But we're not going to touch the UVs at all. We're going to do everything in the nodes. We'll work with just the plane for now, as we don't want to start distorting everything yet. If you've watched my previous videos on eyes, you'll be familiar with the good old mapping node. The mapping node is our best friend for all things related to moving things around. I'm not going to explain everything about it, but let's work with it on texture mode, just so that it stays consistent for this video. The mapping node lets us make pretty much the exact same transformations we were just making by moving our UV grid. We can move it on X and Y to go up and down. Moving on Z does nothing because Z would be straight towards us, and UVs are a 2D space, there's only U and V. And of course we can rotate it on X and Y, and this gives us kind of 3D behavior, but the only rotation we really care about is Z, which is rotating around the axis we're looking down. And of course, we can scale. Now, the important thing to note is that all these transformations are happening with a pivot point of the bottom left corner, because that is 0x and 0y. X, of course, 0 to 1, and y, 0 to 1. If we want to isolate just one symbol, here's what we need to do. We get a value node so we can change all three scales at once, and then we scale it up to times 3. And since before these symbols were a third of the canvas, then that's pretty obvious. It's that simple. If we want to move to a different symbol, we use the x and y location. In this case, positive x moves the texture to the right. So if we want to move to the symbol to the right on the texture, we actually have to go negative. -1 moves us by one whole symbol, because that's a third of the total size. And it's the same on y. So this lets us select which symbol on the grid we want. This mapping node will be the heart of our entire setup, so let's check it into a group and start setting things up. We know we're going to want to control the x and y and the scale overall, and we're going to want to be able to control those from outside the group. In order to target just 2 of these channels instead of all 3, we need to use a combine XYZ. So we'll have one of these for the location, and Z doesn't do anything because it doesn't matter here. And we'll also have one for the scale, but in this case, we'll default all the values to 1. To save us some time, I'm going to handle all of the group input, setup, and node organization off-screen between cuts. Here is our initial group setup. I've made x and y inputs for both of these nodes and called them target and total for each. And that's because the scale is essentially telling us how many rows and columns there are in the image. And the target is letting us choose which one we're actually going to get from the group. And I'm starting all the group names with RMT, which stands for Random Modular Textures, just for organizational purposes. So we can already try this group on our other texture, which instead of 3 by 3, this one is 6 by 1. So we're going to need different setups. There's 6 columns, but only 1 row. And now it's selecting only the first in there, but we can go left to scroll through the rest of them, except I've made the minimum value 0, so actually we can only go right at the moment, which is flipping around and going backwards. There is a reason I set that 0 minimum. Let's go back to our 3 by 3, and I'm going to open up the image editor so that we can keep track of what's going on as we navigate over this texture. So currently we are on the first symbol, which we could call x1, y1, and then this would be x2, y1, and x3, y1. But since it's coordinates, we actually start at 0, and our number here says 0. So this is 0, this is 1, and this is 2, and that's kind of confusing. I'd much rather things be human readable. So let's put 1 into this group, and now we're up there. So how did that happen? Well, it's because of that negative-positive flip. Moving by +1 moved the texture that way, so we're actually looking at this square, which would have wrapped back around here, and moving on the Y would have gone down here, which wraps back around up here. So those both combined to give us this one. So let's change that behavior so that our node controls aren't totally unintuitive. We'll get ourselves a vector math node, set it to scale, plug it in there, and set that to -1, which flips everything. And now we have a different symbol. Now we're on the middle symbol. And that's because of our previous problem. If we go back to 0, 0, we're at the bottom again. So now 1, 1 is actually 2, 2, which is the middle. But at least we move in the right direction now. If I do this over, when we go a lower number, we now get the symbol on the left. So let's fix that other problem. We need to offset our input by 1. So let's get ourselves another vector math and set it to subtract. And we'll just subtract 1 from each of these. We're just going to keep ignoring z because we can. And let's do this real quick just for organization. And now 1, 1 gives us that, and 2 gives us that, and then y2 moves us to the center. And now our coordinates are working properly. But it is still possible to enter a decimal value and end up partway between two symbols, so let's get rid of that too. We'll do that by grabbing a math node and setting it to round. And round rounds you to either up or down to the nearest full integer, the nearest full number. And we'll just get 2 of those on each of those inputs. And to avoid any future trouble, we'll also put them on here. And these organizational frames magically appeared between cuts. Now, we can no longer be stuck between symbols. It flips over when you go from 0.5 to 0.4. I mean, technically, you can go to 0.499, and then it flips at 0.5 because it's rounding to the next number. It would be nice if inputs could take integers only, and that when you clicked, it went up by a whole integer. But this is fine because we can scrub it. And let's give ourselves a reasonable limit on these. Max value of 3 and minimum of 1. So that we can conveniently flip between our different symbols. Now we can manually navigate our textures via our group controls. So if you're using this to manually select, then it would be pretty easy to work with this group. Of course, we'll be plugging random values into these in the long run. The next feature we're going to want is some more control of the texture's transforms. It would be nice to be able to control the rotation and the scale. So we can get ourselves another mapping node and make sure it's not set to anything and plug that in. But if we start doing some rotation, we have this problem that we are still rotating from the bottom left point. And let's move ourselves over to number 3, 3, 3, all the way at the top. And if we rotate, it becomes very clear that even though we're up here, as we rotate, the rotation point is still down here, even though we have scaled and moved the texture. So this is a bit of a problem. What we need is to be able to rotate around the center of whatever symbol we're on. And it's the same problem for scale. It's scaling down to that bottom left corner still. So how do we deal with this? Well, first, it's easier if we make these changes to the UV vector before this mapping node, just to reduce the number of variables that are involved. So we'll plug that in there, and that in there. And of course, we've got the same problem at the moment. It's still working around that point. Let's plug this straight in here and bypass those changes for the time being. So we need to move our center of rotation. And we can, of course, do that with the location. And that's moving the texture. And now when I rotate, it is rotating around the center, but the texture has moved. And if I scale, it is scaling to the center of what we're looking at. It's a bit confusing when it goes negative. So that's actually the behavior we want. But we're not looking at the right symbol anymore. If we go back here, because we've moved everything by half the grid. It's 0.5, half of 0 to 1. So we just need to move it back after. Now it's centered again on the right symbol. If we look here, it lines up perfectly, and it's rotating around the center, and it's scaling around the center. So essentially what we've done is we move our texture and do our transform, then we move it back, and then we pick our tile. So everything is behaving properly. Now I'm going to set up some inputs for this. So here's our inputs. I've used the combine X, Y, Z again. And for the rotation, we only care about Z, and for the scale, we only care about X and Y. You could put them as separate inputs if you wanted to control them separately. So now, if I scale it, we get the expected behavior. And if we rotate it, it's spinning right, but it's actually rotating the opposite direction than I'd expect. I'd expect a positive rotation. Since I'm scrubbing to the right, I want it to rotate right, but it's going left. And the values are a bit weird. I want 90 degrees, and that's not 90 because we're actually stuck in radians here at the moment. So let's fix both of those issues. We will use the good old math nodes again, and similar to how we did before, we will flip the direction of the rotation by multiplying by -1. That's a little bit more room there. And we need to solve the radian problem, and that can also be a math node, and we can get the 2 radians. So that will cause it to treat that number as degrees. Everything nice and tidy. And now, this rotates in the direction we'd expect and in the numbers we'd expect. 45 is a 45-degree rotation, 90 is a 90-degree rotation, etc. So that's working so far, but as it usually does, we've introduced a new problem for ourselves. As we scale things down, the other symbols become visible, where we want to be able to scale our symbol down and have everything else remain the background color, white in this case, and not have all that other stuff appear. So we need a fix for that, and the fix will be a mask. Luckily, it's not too hard to use mostly the same vector adjustments we've made here to set up a mask of the symbol that we've selected. Let's look at the basics. We'll start with our UV and split it. And then we can look at just our X or Y, and that looks pretty crazy right now because it's plugged into the texture. So let's make a new output there and view that at the moment. So our X is a gradient of 0 to 1 from one edge of the UV square to another. But currently we can see this isn't going from 0 to 1, and that's because we've zoomed in by a factor of 3, effectively. So we can think about how we can make a mask here. First, we'll make this easier to visualize. Let's look at our texture again, and we're going to set everything back to 1. Now let's look at that X again, and we can see the full gradient from 0 to 1. Now we can set up math to isolate just one area of it. Let's say that we do a greater than, and now we can split it in half, or if we make this a third, now we can isolate just 1/3 of it, which is what we're going to need in the end. So let's get a greater than and a less than, and we'll set this to be 2/3. I think that's the right number. Get another math and multiply. Let's see. Yes, so the greater than is giving us that. The less than is giving us that. So if we multiply the two, which darkens them, now we've isolated the middle column on X. But currently, this is kind of hardwired to thirds. We want it to automatically adjust with whatever number of columns we set. Because what if we had a 4x4 or a 5x5 texture or some other amount? So we want to use our previous controls and make them work with this setup. Let's grab ourselves another a separate XYZ. I'm going to take our input here, our target column and row, before we flip them, and bring that over here. And we're going to make it so that X is the threshold. And then that X again plus 1 is the threshold, well, the threshold for the less than as well. We also need a new group input. We'll just use the base UV now so that we can see what I'm about to do. I'm going to set our columns back to 3. We still can't see anything because we need a map range node here with clamp off. And we'll plug our X into the max. And now we see a mask where we have masked to the first column on X. And if we adjust that, we can flip which column is currently being controlled. And now that's cleaned up a bit. And if we go back to our real proper UV and then scale, we can see that there's actually a mask on X controlling what we can see. Well, it's not actually controlling what we can see until we do this. And now it's controlling what we can see on X. And now I have duplicated the setup for Y, and we can see as we scale that we don't see any other symbols. If we look at the mask on its own, it's just a white box. So just to recap exactly how this works, when we are scaling our texture, we end up with the value being 0. We're only looking at this much of the image right now. So it's 0 to 1 across the whole thing, but we're only looking at a third of it. So when we use the map range powered by the same number of columns, 3, we are adjusting it so now just the area we're looking at is 0 to 1 again, and then the mask that I showed earlier works. And we can check this on our other texture. Let's make a copy. And of course, we'll need to set this to be 6 by 1. But our mask still works automatically, even though we've changed the dimensions because of the controls we set up. So that's the most complicated part done, actually. We can get rid of the image view, and I'm going to re-enable our charm. And of course, we're seeing the same thing, but it's not stretched on the plane, and it's squished down to a third on the charm. And now the next task is to get 3 copies of 3 different symbols, put them in the thirds of the charm, and then feed them some random numbers. We'll start with checking this group into another group. And we won't need most of that. And we can set that to hide. And we're going to need 3 things. We need a mask of the areas we want to work with. We need vector changes for those 3 areas, and we need random numbers. Let's start with the mask because it is quite easy. We'll do our usual map range and get some math for greater than and lesser than. It's a good way to isolate one area. We won't need to multiply them this time. And I'm going to keep looking at the mask output just so we can see what's going on outside our group. We'll take our UVs, separate the XYZ again, and we're going to be working just on the Y, the vertical component. I said greater than and less than, but actually it needs to be 2 greater thans. We'll plug our Y into our map range, change to stepped linear, set the steps to 2, and now we have 3 distinct areas. We'll have one above 0.5, that masks the top third, and this one with the threshold will just be 0, which masks everything except the bottom third. So that's our masks set up, magical off-screen cleanup. We'll disconnect that. I'm going to reconnect our texture, but without the mask, and we don't have that group at the moment. And the next thing we need is 3 separate locations on the y-axis. We need 3 different versions of our y vector. And what I mean by that is easier to show than to tell. Let's plug that back in, and now we can see our whole texture. So we're used to changing our y location with a mapping node, and then moving it on y, and we can do that, but since we only need to change y, we'll do it a different way for educational value and other reasons. We're going to use my favorite map range node instead. So if we take y and we run it through a map range, then if we change things here, this is actually a scaling effect. And what we can do is, say I do 1/3 here. Now we've scaled our texture down quite a bit. And let's bring back in our main group here. And what we're seeing is now we've switched. Now the plane has the textures squished, but we have 3 textures on our card, which is what we're looking for. We have 3 different symbols. And that's because of this map range node switching things down to 1/3. And if we take a look at this result, what we're looking at is a mask of 0 to 1 that takes place over 1/3 of it, and then it's all 1 after this. So that's pretty interesting. What if we make more of these? And this time, I'm doing 1 divided by 3 to 2 divided by 3. Oh, gotta type that right. So now we're looking at a mask of black to white in the middle third. And same thing here, 2 divided by 3 all the way up to 1. And that is the upper third. Now we will use our different area masks to use a different Y location dependent on the area. And we do that with a mix RGB. And a couple of mix nodes. So now if we look at this, we have 3 0 to 1 gradients. So we've changed from just one gradient from 0 to 1 to a repeating 3 of them. And we could change these to be different sizes. That's part of why I use map ranges. If you wanted to have uneven sizes, you could have different things in these map ranges, or use different masks here. Now let's look at what happens if we look at our texture. Each of the symbols is the same. In fact, it is the one that we have selected. If we go to it, whichever one. So now we have 3 different areas of our mesh that are all showing the same symbol chosen off our texture. Now with our setup restored, we can see we've got a bit of a problem. Where's this line between the symbols coming from? If I scale it up, it gets even worse. That is actually an Eevee bug. If I switch over into cycles, it disappears. And there is a fix, which is you go to your texture and you change it from linear to cubic. And I have no idea what that means, but it fixes it, and it's still fine in cycles, and it doesn't cause you any problems. Now, let's see about also using our area masks to feed some different inputs to our get texture group. I'm going to grab a mix node again, and a couple of values. And if we take a mask here and plug that into the FAC, and put that into our target column, let's say, and now let's put in 2 different numbers. And now we've changed it. In the masked area, which is the top 2 symbols, we have changed which symbol it is, because we're telling it to use a different value into target column in different areas of the mesh. So now we need to get ourselves some random numbers. Let's look at our options. The most commonly known option is the object info node, which has a random output. This gives you a random number between 0 and 1, and it will be different on different objects. Let's take a look at it. If we plug in our mask, we can see that on the plane, it looks like it's a mid value, maybe 0.3, and it's much darker here. And if we make more objects, every one of them has a different value. So that's great, but that's only one random value per object. What happens if we want more? Where else do we get them from? And the option is, actually for a long time, there wasn't another way to get them except to use drivers. But back in, I think it was 2.81 or maybe 2.82, we got a bunch of new procedural nodes and a bunch of new modes, including this 4D mode. Let's take a look at our white noise texture here. It is giving us actually a random number. And if we plug something into its vector input, like let's do a combine here, and we change this up, it actually changes what number it is. So white noise is a great texture where it just gives us the same random value on the whole piece of geometry, which is way more useful than you'd expect. And it has another fancy feature. If we put it on 4D, which is a 3D texture with time, W is time usually, and normally you'd use W, you'd animate it to be different on different frames. But in our case, if we scrub it, that's another way to change what value we're getting. So we can play with any of these actually to get different random numbers out of this noise texture. Also, white noise actually gives either value or color, so we can separate the RGB and we'll see that we actually have 3 different random numbers here, although they're pretty similar at the moment. Let's change that seed, and maybe they'll be more different now. There we go. Now it's clear that there are 3 different ones. So what works really well is you get your object info, you put that random into the vector, and now you have 3 random numbers that are different on different objects. And then you can adjust W to get some variety or to tweak it. Or if you were using multiple white noise textures in the same material, you'd give them different seeds like this. And now we have 6 different random numbers that are also different per object. We could even go completely mad with power and take the output of one white noise texture and make that the W seed of the others, and just have white noise powering white noise, and everything is just random upon random. And this will be the core of our random numbers group. I've tossed that into a new group, which we will call... This will just be a group that exists to give us a source of a bunch of random numbers. How many? Well, we're going to end up needing 6 for this setup. So I'm going to make it so that it outputs 6 different random numbers. And if you need more than that for something else you're doing, you can make even more. Unfortunately, there isn't an easy way to do like a loop like you would in coding to tell it to output a whole list of them. But that's just the limitations of material nodes at the time being. We also need this group to have the functionality to change the range of our random numbers. By default, they're all between 0 and 1, but we need numbers between 1 and 3, so we're going to break out the good old map range nodes. And we'll need one for each of these. This is going to get a bit overlapped, but that's just how it is. And let's get the group input node. And we're going to need to make the 2min and 2max into inputs. There, so that's the inputs, and I plugged all those in and made some outputs, and now we're just going to copy and paste this for the second set. I don't believe there's a more efficient way to do this, so if someone knows one, I'm very interested in knowing. But for every 3 we need, we just copy the noise texture and this whole thing again, and eventually we'd have to chain more white noise if we want more than 9 of them, I suppose. But yeah, this'll do for now, so I would like to know a more efficient way. That's done. If we take a look, we can see we do have 6 different random numbers, and they're different on each object. Now, of course, these are all different shades of gray, so they're not that different or that exciting. And then we can scroll the seed to get different ones, and I can set these to be from 1 to 3, and now it all looks white, but they are different numbers. So now we can see about using these random numbers. We've got our mix node and our mask from before. So our mask is black at the bottom third, so that will be the first random number. And then the second 2/3 get the second random number. But then we will bring in our other portion of the mask, which looks like that. So that will be where it's black, it's the first 2, and where it's white, it will be the third random number. So now we have 3 random numbers that change with our seed. Now I have cleaned up and organized the nodes with all of them plugged into the mixes and labeling so we can keep track of our masks. And let's change our min and max back. We've got our seed, and now we can plug these into our 2 target columns. And we have randomized symbols. They're random on each object and different on the 2 objects. And if I mess with the seed, they change. Random on X and Y. And of course, that'll be an input. Before we move on from our random numbers group, though, let's add a little bit more functionality to it, because we might want to reuse it in the future for different things. And what I'm going to add is geometry random per island. Now, random per island gives you a random number per mesh island. So right now, we get different things for different objects. But what if you duplicated the mesh in an object? That's still the same. So let's add the support for this to give us random numbers on different pieces of mesh too. And there is a caveat, which is right now random per island is only supported in cycles. So for this bit, I will switch over to cycles and set my sampling to be something really low because we don't really need much to see this. And plug in random per island. And now we have different things on different islands of the same mesh. So this one has 3 pieces, but we can see this object and this object on the first island are still the same. And if we duplicate an object, it's the same. So we need both random per island and random per object functionality. So let's get that. It's pretty easy. We'll simply get a mixRGB and add our 2 random numbers together. And now we have both. We can see this object and this object have different things. And if we do some duplication, it's working. But it's lagging my viewport. Back to Eevee, and it stops working. And I'll get rid of this one now. And the reason I'm including this is because this is being added to Eevee soon, I believe. So by the time you're watching this video, this feature may exist. So it's good to have. And now I will make it a bit fancier. And I made it fancier and added inputs to control the FAQ of these ads so that now you could turn these off if you wanted to. And of course, in Eevee, random per island is just outputting pure black, so it just doesn't have any effect at the moment. So we'll just leave it on, but ignore it. Now that we have a good source of random numbers from this group, we can move on to our next major feature. And at this point, we can stop looking at this plane and just look at our card here. And let's check out that mesh and take note that in the mesh, I have a border. And that's a guide because I want to have these symbols be a bit smaller. Right now, if I add the border texture, it's going to cover up these symbols. So I need a way to shrink this down while keeping everything even. I can scale down the symbols themselves with my scale control. And if I scale them down a bunch, that frees up space on the border. But I want to make this more complicated and more fancy, because what I want is for these symbols to instead of appear within this inner section of the mesh. To pull this off, we're going to need to do an adjustment to our UVs at the beginning of this group before they get used much. And as usual, that adjustment is going to be based around my favorite map range node. This time we can leave it on linear. So let's take a look at what happens if we separate and combine our HSV, or XYZ, as we have done many times now. And now drop in that map range, and let's bump up the from min and bump down the from max. And that just gave us more space. And we can do the same thing here, and that's giving us vertical space. And, we can adjust these. And what's actually going on here, if we steal our output node and come all the way over here and look, is that, as before, we're changing what area is 0 to 1. So before, it's the whole thing. And now we are adding a margin to that. And that effectively scales our texture in to this central area. I've run out of words there, but let's just make the setup. We'll get ourselves a number, which 0.1 is a good amount. And what we want to do is add it to 0 to be our from minimum. And then subtract it from 1 to be our maximum. And I'm going to close these up because we don't really need to see that in detail. And the same thing here. But we'll have a different number for the X and Y. So second slot on those. And of course, I'm going to clean this up and make inputs of these numbers. And there's the setup, cleaned up and organized. And we can go outside our group and we can give these a nudge inward a bit, maybe 0.05. I can put in different values for X and Y, but then of course that will squish or stretch the texture. But you can do that if you want to, or if you need to for whatever reason. Or you could even set up random numbers into these too. I didn't mention it before, but you could also get another random numbers group with a different seed and put random numbers into rotation and scale and whatever it is that you like. Yeah, let's put that 9.5 there. That looks like it fits decently. We'll see how that looks when we put the borders on in a minute. Most of the hard work is done. Doing the border setup will be much easier. I'm going to make a copy of the same group. This will be same inputs, and for the borders, we don't need most of this setup actually. So I'm going to come in here and delete all of this stuff to do with the area masks and the random numbers. I'll let the border margin control stay. I'm not going to use it, but I'll leave that there just in case I want it. And change my mind next time I'm using these. And this time we're going to need some different numbers. We're going to use a 6 by 1. Our Y target row doesn't matter because there's only one target row. And so we actually only need one random number for this. Grab our random numbers group again and get our seed input. And this time we just need one number into X, but it needs to be from 1 to 6. Right, because of the border. Plug in our mask. And now, there we go, our 6 different border types. Now let's get some mix nodes to combine and color these. And there they are. Black for the border, white for the background, red for the symbols. But let's get some more interesting colors, and of course we'll randomize those as well. Randomizing colors is easy because of our random number group getting used again. This time we'll leave it on min and max of 0 and 1. And let's get ourselves some color ramps, which I rarely use, but there's actually a good place for them. Constant, put this one to 0.5 position. This can be for the border color. Let's say the border is allowed to be black and red. We'll plug in that. So now we're getting a random number between 0 and 1, so it's a 50-50 chance of black or red for the border. So if we now go and make some more of these, about half of them will have red borders. Same process for the background. This time I'll make the options yellow color and white because that's what I used on this before. It gets another random number. And for the symbols, third random number. And these can be, let's copy that one again because I want the same colors, black or red. And of course, our seed will change it up. But we can also use the color ramp to change up the likelihood of a certain color. So let's make this two-thirds. So now this is a 2/3 chance of being black and 1/3 of red. And I want this one to be 1/3, so they're more likely to be red. And there we go. So color ramps are convenient if you want just a couple colors and if you like be able to change the weighting. But another way you can get lots of colors is you can make a mega mix group like this. And what this group is doing, I'm not going to show the setup in detail because it's just the same thing copied over and over, is we bring in 6 colors and we mix them based on a random value. And that is, well, we have 6 values. If the number is between, in 1/6, it'll get the first color, 2/6, it'll get the second color, etc. But it is being controlled. There is a field to adjust the number of inputs used. So let's turn that to 1, and we'll use this for our symbols color real quick. Let's get a bunch more of these. And right now it's only giving black on the symbols because I'm only letting it use 1. But if I say 2, now it's 50-50 black and white. Of course, we can't see the white. Let's change that to something a bit more visible. And if I allow 3, now it's 30% chance of each one, or 1/3 chance. And it goes all the way up to 6. And you could add even more colors and just keep copying this same node graph and stretch it on into infinity for however many you need, if you need an absolute crap ton of colors. So that's it. We've done it. The nodes are complete, and now you can just copy to your heart's content. You can adjust your seeds, all of your seeds, change whatever you need, and yeah, just go wild with it. Figure out something else to use it on. I'm hoping to do a follow-up Reimu project at some point where I use a lot of these controlled by a particle system. So that's what I really made this for. Thank you again for watching this video. If you have any questions or comments, leave them down below, or you can message me at any of the social media accounts on my About page. I will give you help and technical support if you can find anything wrong with it or break it in some creative way. And of course, please like and subscribe, share it around, follow me on Twitter. If you make something using this technique, tweet it at me and I'll retweet you, or send it to me and I'll share it, whatever. And please support me on Patreon so I can keep making things like this, or pick up the file on Gumroad and save yourself a lot of setup time. Thanks, and I'll see you next video.